you don't have the value of this angle. That's why we have to follow that procedure. We now say angle on a straight line is 180 minus 40, which will give us the leftover angle we are looking for, this part. So that is that. Now the next vector of force is 16 Newton. So we are going to measure our angle from this part. We will move round. Is our angle we are going to measure from this part so you get to these whole points. Now this is already angle on a straight line, and from here to here is 90. So this whole angle from this positive x-axis to 16 Newton is 180 degree plus 90 degree, which is 270 degree. Now go to the next force, which is 15 Newton. Then you move around your angle from here to you move to the vector. So this whole angle from here to here. So we already know that from here to here is 270. So you just add the extra 30, which will be 270 plus 30, which will give us 300. Now, the advantage of this method, because you are picking the angles with respect to the positive axis using 360 degree, you don't have to pay attention when you are finding the x component, which coordinate it is on, whether it's found the x coordinate is found on the x axis or the y axis. So you don't bother to put negative sign and positive sign. So we still employ our formula to find the x component, which you know is f of x is equal to f cos theta. So this time around is 10 cos 0. This is what? 10 sine 0. This one is 12 cos 50, and this is 12 sine 50. This is 140 20 cos 140, and this is 20 sine 140. This is 16 cos 270, and this is 16 sine 270. This is 15 cos 300, and this is 15 sine 300. So I'll just write out the values quickly. Once again, using this pattern of finding your angle, you don't have to look your x component whether it is positive or negative. We are not interested as it is located, because the way we are tracing our angle, we are using 360 degree from the positive x direction. I'm quickly going to write out the values now. With that done, I'll quickly write out the values for this table. If that is 10 cos 0 is this, 10 sine 0 is this, this is the answer of this is the answer of this. I've written out all of the answers out. Now, if you cross-check the table we did earlier on and this table, you will see that we arrive at the same answer. We arrive at the same answer and the others follow up. So it is still the same method, resolution of vector, when you are summing more than two vectors. But when you want to choose your angle, you cannot have two methods of choosing your angle. We have done the first method and this second method. The only thing is, in this second method that is different from the first method is how we choose our angle. Unlike the first one, that we said theta is the angle that it makes from any of the x-axis. But this is the angle theta make with the positive x-axis. Why I prefer this second method, when you're finding the x component, you don't not bother to place a sign, because where the method Means that you have to find the x component, whether it's on a negative x axis or negative y axis or positive x axis or positive y axis. But this, you just have to choose your angles correctly. The answers and the signs will come out in place. That is why I prefer the second method. Then everything follows from here. Recall, or once you have gotten your x component vector and your y component, endeavor to draw it on a diagram so that you'll be able to get your resultant vector, magnitude of your resultant vector correctly and your angle correctly. We call this part, we opposite was 6.96. We omit the sign. The sign is only telling us the direction. We have already drawn it to the direction. It's going this way because of the negative sign. Now once you have that, you are only picking the values. Please do not take the minus sign with it. So this was the direction of the resultant vector. We say we can also use south, east, north, west, 4 cardinal points to give the direction. Now that is that. Now in the subsequent class, what we want to now do is to add vectors that can be found in three-dimensional plane. Three-dimensional plane. All these vectors we have been adding, they are coplanar vectors, and they are always acting at points. What about if you have vectors that are on three-dimensional plane? How do you go about in adding it? That is what we want to do. See you there.